Now we have to be continually see next methods to determine that Q values we have to be quickly see. One is called temporal difference and another one is called Bellman's equation. So what is that temporal difference? Let me say, the temporal difference formula that calculates the Q value by incorporating the value of the current state and action by comparing the differences with the previous state and action. So this is so simple. It's having the value of the current state and action by comparing the differences with the previous state and action. So simply we say what difference that has been happened between the previous state and then so current state. So that measurement, it's called the temporal difference. And the next one is called, that is the Bellman's equation. This is derived by the mathematician, it's called the Richard Bellman, and he invented this equation at the year of the 1977 as the recursive formula for optimal decision making. In the case of that Q learning context, the Bellman's equation usually used to help calculate the value of a given state and access its relative position. And the state with the highest value is considered as the optimal state. So, in Q learning models, work through trial and error experiences to learn the optimal behavior for a task. So, the Q learning process involves modeling optimal behavior by learning an optimal action value function or the Q function. So this function represents the optimal long-term value of action A in state S and subsequently follows optimal behavior in every subsequent state. When we are talking about that Bellman's equation, the equations may be capital Q of S comma A. That means start and then action, that equal to Q of S comma A, that should be added with alpha, that should be multiplied with R plus Y, and maximum Q of S dash comma A dash, that subtracted from Q of S comma A. So this equation breaks down as Q of S comma A represents the expected reward for taking that action A in state S. The actual reward received for the action is referenced by that or, while S dash is refers to the next state. The learning rate is alpha and gamma is the discount factor. The highest expected reward for all possible actions A in state S is represented by the max of Q S dash comma A dash. Now we have to be quickly see into that understanding of that Q learning. So now we are having, that is one building environment. So there we are having the 5 rooms and then 4 doors. So the destination is I have to reach out to that outside. So you can easily able to understand we are having 5 rooms, that is numbered as 0, 1, 2, 3, 4. And now the agent is having that goal to reach that building outside of that room 5. So this is the task that has been assigned. So now that has been put into the graphical model and the goal state that has been defined. The agent is resided in that 0, the agent that has to traverse and then reach out to that goal. So represent the room in that graph. So now it has to be traverse all these things and I am giving, that is that weightage, and then so reward when the agent that has to be reach out into the goal state. So the reward that has been assigned, the doors lead immediately to the target is assigned to the instant the reward of 100. So the other doors are not directly connected to the target room, having the 0 reward. So for example, the doors are 2 away, 0 leads to 4 and 4 leads back to 0. So 2 edges are assigned to each room. So each edge contains an instant reward value. So which reward it's having that maximum, so that room it's having the leading to reach out to the goal state. So the agent moves to that 4 to 5 and then it will receive the reward of that 100. If the agent moves from 5 to 4, so it will give a reward of the 0. So this way we have to be implement these things. So now quickly we have to be consider if that agent resides in the room number 2, that's the starting state of that S. The agent movement from one state to that another, this is for that action A. The agent is traveling from the state 2 to state 5, that is the target. So through by current state is the 2 and there's a transition state from 2 to 3 and then 3 is having that the chances of 1 or 4 and then so from 3 it has to be moved to that 5 either by 1 or by the 4. So in case if it is backward to the 2 and then it will be rewarded with that 0. So for this the matrix that has been so drafted. So this matrix is called that is the table or matrix. So -1 denotes that no edges, 0 represent that indirect edges to the target. For this entire transition the matrix that has been drafted. Okay, so continually we have to see how the Q learning is working.